how to convert a decimal number into a rational numbers, that is in a p by q form. Okay, we know that a rational number can be represented in the form of a decimal number, that in a repeating and a non-repeating pattern. Okay. Okay, now we will see. Let's take an example. How to represent 0.25 in the form p by q. Okay, this is the decimal notation. This is the fractional notation. Both are rational numbers. Okay, just the representation. This is called decimal. Okay, we know that 0.25 is nothing but a it has 2 tens and 5 hundreds. When we mean tenths, THS, it is 1 by 10. You have to multiply 2. Okay, this is the tens place. This is hundredths place. Okay, hundredths. So we multiply 5 into 1 by 100. In this case, it is going to be 2 into 1 by 10. That is equal to 2 by 20 plus 5 by 100. Multiplying 10 times on the numerator and denominator, we make the denominators common, right? So 20 by 100 is equal to 5 by 100. Now since the denominators are common, we can just add the numerators, right? So 25 by 100 equal to, how can we represent 25? How many times? 25 4 times is 100, right? So hence we got 1 by 4. This is how 0.25 can be represented in the p by q form. P is numerator, q is denominator. Okay, this is how we do that. There's another easy way, but just for your example, okay, we can say 0.25. We give 0.25, we divided it by 1. Okay, we can represent this as natural number, right? Now multiply 100 on both sides, on the top and the bottom, because we have 2 decimal points. So 25 by 100. 25 how many times? 4 times. That is equal to 1 by 4. Okay, this is another way of getting to the answer. Example 10. There is one more. How to represent. Find the rational represented by the decimal 0.6575. 0.675. That is, this is the number given. Okay, this how many tenths we got? This is the tenths position, right? 6 tenths. How many hundreds we got? This is the hundreds position. We got 700. And how many thousands position? What is this? This is the thousands position. We got 5,000. Okay, so tens means 1 by 10, right? So we present tens as this one, and we represent hundreds as 1 by 100, and we represent thousands as 1 by 1000. Okay, so multiplying that appropriate number 6, 7 and 5 to their decimal notation, okay, we get 6 by 100, 6 by 10, right? Just to make the denominators common, we got, what is the highest LCM of this is 1000, right? So we multiply by 100 so that we get the denominators common in all the three. In the second case, we need to multiply by 10. Here we don't have to multiply anything. So the answer is 5 into 5, 5, 7 into 10, because we have to multiply 10 on top, 100 here. Okay, so now since the denominators are common, we got 600 plus 600 plus 70 plus 5 is going to be 675, and the denominator is 1000. Now dividing it by 25, we got 40, 27 times. So 27 by 40 is the decimal notation, rational notation, representation of a decimal number 0.675. Another example 11. Find the rational number represented by the non-terminating decimal 0.35. You notice this one dash on the top, that means that number alone is repeating, 3 is not repeating. Okay, so let x be the rational number. Let us assume that rational number is be represented as x. Then x equal to what? X is equal to the number given here, right? So x is equal to 0.35. Since this number alone has the dash, this number repeats. Multiplying both sides by 10, we get, because we want to have the repeating number alone, eliminate the repeating number on the right hand side. So we have to move this decimal point one digit, right? So we have to, for that we have to multiply by 10. So 10x is equal to 3.55555, right? This is step number 1. Also multiplying both sides by 100. If we multiply one other thing, we need another one. So here we multiply by 100, so we get 2 digits to the right and the rest goes on repeating, right? If we subtract, that's the second equation. If we subtract this from this, we get what? 900 is bigger, so we do the other way. We take off 10 from 100, how much it is? 90x equal to, how much it is? 35.55. It's going to be 32, because these things anyway get cancelled out. So 35 minus 3 is equal to 32, is equal to 32. So x equal to 1, 32 by 9. So dividing by 5, we use 5 to eliminate 1. No, 5 is not the common thing. We will do 2, use 2 here, so we dividing it by 2, we get 45, and here is 16, right? So this is the number. So here is the one we assumed. That assumption is equivalent to the rational number of the decimal notation, this one. Okay, this is equal to this. Okay. One more example, convert the decimal 0.431 into a rational number of denotation how? P by Q. Okay. We have the bar on the top. This bar denotes the entire 3 digits are repeating, like 431, 431, etc. Okay. So how we do here? Let us see here. The same way we assume x as the rational number, which is nothing but this one, right? So x equal to 0.531, that is equal to 0.53, etc. This is equation 1. Okay, we need 3. Since 3 numbers are repeating, we will bring the 3 to the left. So to bring the 3, we have to multiply 3 with 1000. So the decimal point goes here, right? So 431 and the thing goes on. And we do it subtracting 1. This is the second equation by multiplying 1000. This is the first equation without the 1 times x. Okay. When we subtract 1 times from 1000 times of x, we get 999x, right? So this is minus x, right? X is equal to this guy here. Okay. So this thing goes off on either side. The reason being these are all repeating numbers. We have what is left out is 431 because it is 0 here, so we got 431. The corresponding size 2 we have 431. So x equal to 431 divided by 999. Since there is no commonality, we cannot simplify it. So this is the rational number we were talking about in the beginning. Okay. Answer. With this in mind, do all the exercise 1.2, 1y, answer with actual division. Okay, you have to give reasons.